Hi guys, so today we are going to be talking about surface area of rectangular prisms. So we have already talked about surface area of cylinders, so remember we are opening up a 3D figure, laying it down flat on top of a surface, and then we are going to find the area of that. So surface area is pretty much the amount of space on the outside of our 3D figure. Okay, so just like a surface area of a cylinder, the surface area of a cylinder had a net, and the rectangular prism does as well, because whenever we open up the figure and lay it down flat, it will create some type of net to help us find the area of it. So I found a video that demonstrates this, so I just want you guys to watch it and see what happens.
Three-dimensional solids. The two we're going to focus on here in the 7th grade is the net of a rectangular prism, which is your basic box. And if you look at this picture, you can see that I have right over here a rectangular prism, and even gives you the dimensions. The length is 10, the width is 6, the height is 7. And we're going to figure out its net. Well, the net is very simple. It's like if you cut this along its edges and laid it out flat. It's kind of like deconstructing a box. Okay, your normal cardboard box, say a shoe box or something, something shipped in. If you cut the lid off, perfect. So if you watch, we'll show you the net, and we'll show you how it folds down and up. And you'll notice that the nets have a pattern. If you look here, you'll see this is the overhead view. Notice when you look here, all you see is this green rectangle that's on top. This would be 6, this would be 10. Okay, they also rotate. But here we go, watch, as I show you the net. Watch it unfold. See how it unfolded? Let's do that one more time. See as it opens up and lays out flat, you can see, look. Here's the top of the box. Cut it off at the top. This would be the right side, the left side. Here's the front. That we call that the back. It's our perspective right. And then you cut those, just twist them out and lay them out flat. And you'll notice they color coded the rectangles. Because think about it, it's a box. So as you can see, this rectangle, the front of the box, or the right side of the box, and the left side of the box. If you'd like to see them at the same time, I'll show you here. They would fold up. That'd be this side. This would match this side. This would match with this side up here, which I can't get to because of the angle of it. But the left and right side of the box, and they're the exact same rectangle. Now, what about the front and the back? Well, the front and the back. Back there. This one here. They have the same. And then the bottom and the top be this green rectangle. The bottom, which you can't get to again, is solid. But watch. Let me fold it back up and you can see it overlaps. So we'll close that. Take a look at it opening up again. There you go. Left and right side.
Okay, so that's just a brief overview of what it looks like. So as you notice, the bottom of the box stayed in place. The sides, everything that was touching the bottom of the box that's connected to the bottom just fell flat right beside it. And then the top was the first thing that opened up, and then it's just still attached to one of the sides, and it is placed on the ground furthest away from the bottom. Okay? So that's the net. So how do we label the net of a rectangular prism? So here's the net that we just watched. Remember, the bottom stayed flat, the sides fell, the back and the front fell, still attached to the bottom, and then the top was just still connected to one of the sides and just fell down. So really, the top could be over here on this side, it could be with the back or the front, but it just has to be the furthest away from the bottom. Okay, so if you notice, we have a rectangular prism here with a length of 13, a width of 5, and a height of 6. Okay, so like I said, we have a length of 13, a width of 5, and a height of 6. So if I were to label my net over here, think about if I were to color in the bottom, what two measurements correspond with the bottom? And hopefully you guys see that the bottom would have a length of 15 and a width of 5. So my two measurements are 13 and 5. So when I go to label them over here, the 13 was talking about the length, so I would put 13 right here in for the length. And then my width would be 5. So my sides would be 5. And obviously, if your length is 13, that means that this length is also 13. If your width is 5, then your width is 5 over here as well. Okay? Now let's move to the sides. So our sides are over here on our net. And if I were to color in my sides, notice how I'm just highlighting the object on the side over here. So what two measurements correspond with the side? So hopefully you guys see the 5 right here. It would be the width of it. And then the 6 is talking about the height of it. So if I were to plug in these numbers on my net, I have a height of 6. And notice how we already put 5 over here from the bottom. And that's also talking about the side, because the 5 shares the side with the bottom and its side itself. So I would just keep filling in my numbers. So 5 is this side, and then 6 is the height of it. Okay? And then notice that if we have one side of the rectangular prism, we also have the other side of the rectangular prism that is going to have the same exact measurements. So if our sides were 5 by 6, our other side, the left side, is also going to be 5 by 6. So I could go ahead and fill those in. And then our last face on our rectangular prism is the front and the back, and this one is a little bit more tricky for students to understand, because notice how when I highlight the front of my object here, a lot of students understand that 13 is one of the measurements for the face, the front of the rectangular prism, but a lot of students do not get this measurement right here correct. But if you notice, our side had a height of 6. So if this side is 6, that means that this side over here is also 6. So my two measurements that correspond with the front would be 13 and 6. So when I go to plug those in, notice how 13 was already plugged in because that was attached with the bottom. And then the 6 would be our side over here, okay? And then same thing, if we have the front that's 13 by 6, that means that the back is also 13 by 6. And then the same thing with the bottom. The bottom and the top are going to have the same exact measurements. So since the bottom was 13 by 5, the top would also be 13 by 5. So if I go to start plugging in all my numbers, we would get something like this. And if you guys noticed, on my net, do you guys see how all of my lengths should correspond with each other, because all of these lengths are the same measurements, so they should all be 13, which if I were to go down, they are 13. All of our sides were 5, so if I were to go across, all of these side lengths should be 5. And then every corner was talking about the height, so every corner should be 6. So that is just a mental note to help you guys figure out if you labeled your rectangular prism correctly. Okay, so we could find the surface area by using the net, because we know that area of rectangles, since these are all rectangles, that's why it's called a rectangular prism. We know that the area of the rectangle is length times width, so we could take 13 times 5, get the bottom and the top's area, 13 times 6 to get the front and the back's area, and 5 by 6 to get the sides areas, and then add them all together to get the total area. Okay, so we could do this, but we are going to teach you guys the formula so that you guys can find the surface area of it. But we just wanted to introduce the net to you and how you can find the rectangular or the surface area from the rectangular prism for it. Okay. So here is the volume formula for a the surface area formula for a rectangular prism, and that is surface area equals 2 times LW plus 2 times HW plus 2 times LH. And remember, whenever numbers and variables are shoved up next to each other, that means that you're multiplying. So all three of these numbers are multiplying, all three of these numbers are multiplying, and all three of these numbers are multiplying, okay? So what do these letters mean? Well, L is our length, so our length would be this side length right here, which would be the 13. W is the width, so our width is over here on the side, so that would be 5. And then H means height, so that is how tall is our rectangular prism, which in this case would be the 6. Okay, so let's use the formula on some different examples to find out what the surface area is. All right, so here we have a new rectangular prism. Again, we want to find the surface area, and the surface area is talking about the space on the outside. So think of like a label. So whenever you guys go to buy something that's in a rectangular prism, the manufacturers put a label on the outside. That is finding the surface area, okay? So let's use our formula to find this area. So start with your formula. Surface area equals the 2 times LW plus 2 times HW plus 2 times LH, okay? And then I like to go ahead and substitute one number in at a time. So our L is talking about our length. So remember, your length is this measurement down here at the bottom. So if our length is 9, we want to plug in 9 for L in every single spot in L where it's at in our formula. So let's go ahead and do that. So notice how I substituted 9 in for L here, and our other L was down here at the end. So notice how I substituted 9 in for L down here, okay? So now we still have some W's and H's, so now let's substitute in our width. So our width is 4. Remember, your width is on the side over here. So everywhere that I see a W, I want to substitute 4 in for it. So there I go. There was a W, so I substituted the 4 in. Here was a W, so I substituted the 4 in, and there was no W down here at the end, okay? So our last letter that we have is H, which is the height. So how tall is our rectangular prism? It is 5 inches. So everywhere where I see H, I want to substitute in 5. Now that I have substituted everything in and I have no letters left, I can now solve this. So thinking of PEMDAS, we need to multiply first. So we need to multiply all 3 sets of numbers that we have. And then our last step would be to add them at the end. So if I were to take 2 times 9 times 4, I get 72. Then if I were to take 2 times 5 times 4, I get 40. And then lastly, 2 times 9 times 5, I get 90. Okay? So after I multiplied all 3 sets of my numbers, my last step is to add these numbers together. So 72 plus 40 plus 90 gives me a surface area of 202 inches squared. Okay, so if you wanted to jump from the formula to this step right here, that's totally fine. Some students just like to work by it step by step just to make sure that they don't forget anything, because if you notice, none of our numbers that we're multiplying are the same. So if you did it correctly, all of your numbers that you're multiplying should be different. Okay. Alright, so now let's move on to a different rectangular prism, and this is what we called a cube because all of our faces are squares, and if you guys notice, all of our measurements are the same as well. So if I wanted to find the surface area of this cube, it's actually a little bit easier since all of our measurements are 12. So once again, start with your formula. Then I like to substitute my lengths in first, so our length of our cube is 12, so I'm going to substitute 12 in for my lengths, or in other words, the L's in our formula. Then I move on to my width, so our width is 12, so once again, all my W's, I'm going to plug in 12. And then lastly, H is our height, so I'm going to plug in my height, all the H's in for 12 as well. and then we should get this. So when we are finding the surface area of the cube, we are going to get the same numbers every time because we have the same side lengths. So 2 times 12 times 12 gives us 288, and we have that 3 times. Add those all together, and we get 864 inches squared.